Hi, I'm Shashank, and I head the AI Labs team at Subex, right? And as Niranjan is part of my team, and Subex is a pioneer in the space of digital trust, providing solutions for 75% of the world's top 50 telcos, right? The charter for me and my team is to build AI first products for telecom and other verticals, and also embed artificial intelligence in all the existing products of Subex. I joined Subex 3 years back, and before that, I have worked with multiple large tech companies, including VMware, Amazon, Flipkart, and Target. And our vision at Subex is to enrich lives through AI-led digital trust. And we figure that for enterprises to adopt and embrace AI into their transformational journey, it is imperative to build trustworthy AI, right? And what trustworthy AI does is that it basically enables AI products and solutions, that are built, delivered, and acquired to be responsible enough to drive trust and wider adoption. Today, I am going to talk about a novel framework of measuring, trust in AI. Now, we all know that there have been quite a few instances recently wherein AI has been in bad light, right? The strength of AI lies in its ability to learn well from the data. However, underlying data is not always true to reality, right? And therefore, if you see, what happens is that when we design certain algorithms, when we build certain models, they're designed to achieve performance, right? But they come at the cost of biasness, lack of explainability, vulnerability to safety and security issues, right? So there have been quite a few instances in recent times, and these have increased concerns on artificial intelligence being biased, affecting people's and organizations' trust and adoption, right? Now, the problem in hand that we have, right, is quite challenging, right? Because when it comes to trust cannot be cannot be looked at from a single lens, right? It's truly multifaceted. It can be psychological in nature than purely technological, right? And can also be largely influenced by cultural and sociological, or cultural and demographic elements, right? Now, what we aim to do is to identify some of the fundamental pillars of AI trust and articulate how they can be measured in some real world use cases. Now, in the previous talk, we talked about counterfactual explanation, and that's one area of explainability, right? And what we have done is that, after several iterations, rigorous research, and based on our collective experiences, right, we have established that there are essentially four pillars or four core constructs of trust, right? And they are reliability, safety, transparency, and responsibility and accountability, right? Now these pillars or these core constructs translate to essentially four dimensions, right? And those dimensions are listed here: performance, fairness, explainability, and security, right? Now, when it comes to performance, right, any AI system should be strong on performance expectations, right, on a given use case. It's very important, because if performance is not there, AI systems will not be trusted, or AI models will not be trusted, and they'll not be adopted. So a threshold performance needs to be there, right? Whether it be accuracy or precision or F1 score or false positives. I mean, you will have to meet certain performance benchmark for the AI system to be trusted, right? The second thing is about fairness, and you can also call it algorithmic bias, or biasness, measurement biasness, or biasness in AI models, right? So when it comes to biasness, right, any biased decision towards a specific group of population needs to be safeguarded, right? And that is very important. So ML biasing becomes a very important aspect, or model debiasing becomes a very important aspect when it comes to trust, right? The other thing is around explainability. We talked about counterfactual explanation. Last year, I talked about the state of the art counterfactual explanation and how we have devised it. We have as community, right? We have taken huge stride as far as explainability is concerned. And it's very important that any decisions from an AI system or AI model are explainable in nature and are also traceable in nature, and that's a very important consideration as far as trust in AI is concerned. And lastly, but not the least, right, and something which has become of a lot importance in recent days is around security, right, and privacy, right. So the model or the systems need to be secure from any malicious or non-malicious attacks, right. So when it comes to adversaries or adversarial attacks, you should have a way to protect the AI system, from the adversarial attack. But the first thing is to measure, how trustworthy the models are, right? Now, as we already talked about this earlier, right? But when it comes to the key regions or the key drivers of inducing lack in AI trust, right? There are quite a few regions, but if you see the key regions, the first one is, of course, that the models are not very well designed, right, or poorly designed, not well built, right. So you build a model, but you don't do last mile optimization, you don't do hyperparameter optimization, you don't have the right set of hyperparameters, you don't have right set of features, you're not done enough feature engineering, you the models are not going to be trustworthy, right. So that's one key reason of lack of AI trust or lack of adoption as far as AI models are concerned. In quite a few cases, right, the models lack explanation, right. Especially we have seen deep learning, right. I mean, we have made huge strides, but there is still a lot of deep learning based systems where explainability becomes tough, right. So that's another reason of lack in AI trust, right. In quite a few cases, we have models which are biased because of biased data, right. So because your training data was not good in nature or was biased, you will have biased outcomes, right, or your model will be biased in nature. Now, in quite a few cases, you also have models which are vulnerable, right? They are prone to attacks. They are prone to adversarial attacks, and there are different types of adversarial attack. We'll talk about those in a later slide and when we are presenting the tool itself, right? But in quite a few cases, models are just vulnerable. And then there is, of course, a drift component or a time-based component wherein the model deteriorates over time, and therefore things like automatic retraining, detecting drift becomes very, very important. So with the earlier discussed core constructs, dimensions, and set of influencing factors. In fact, I did not talk about influencing factors, but these are different influencing factors, right? I mean, these are not limited to this, but these are some of the influencing factors. They can, some of them are in the stage of designing, development, and deployment, and few of these influencing factors are around governance, right? But so we discussed about few the core constructs, right, and the dimensions and the influencing factors. What we have done is that we have developed a model auditing tool which we call AI Trust Calculator. We have leveraged Python, some distributed computing framework like Spark and others, and we have developed a full-fledged AI Trust Calculator which measures and quantifies trust on key pillars of our solution framework to drive trust and wider adoption of AI, right? So of course, we talked about this, but when it comes to performance measurement, it means that the model produces reliable and robust results, right? So what performance measurement does is that it assesses, how well the model meets the expectations and how resilient it is to changing data sets over time, and that's what we call drift, right? It can be so that's what it does, right? Explainability, on the other hand, it ensures that the model is transparent, right? And a model whose behavior can be understood and explained, are the ones which can also be held accountable, right? So I think explainability, basically, if you're able to explain the model, if you're able to explain the black box AI, you are ensuring that your AI framework or AI models or AI systems are transparent in nature. Of course, fairness and de-biased, unbiased models are very, very important. They are important to ensure social responsibility and to ensure trust and safety, right? When it comes to security and privacy, a secure model is safe and reliable to use, right? This particular aspect of the framework evaluates, right, how robust is the model to various adversarial attacks, right, and ensures that model assets are safeguarded from privacy concerns, right? I mean, these are also tightly coupled with a lot of regulations which are out there, right? Now, so what we have done, as I said, we have built an AI trust calculator. It's an operational tool which has been built using Subex's Hypersense AI trust framework. Hypersense is pure play, no code, distributed computing enabled AI orchestration platform, which is leveraged by enterprises around the world. And what this tool does is that it helps user to assess trustworthiness, right, of their AI models and detect any unnecessary risks in the model before putting them in production. Now, the tool has essentially four components on which it measures the trust, right? The first one is technical robustness, and what it basically assesses is how well the model meets the expectations and how resilient it is to changing data over time, right? It also assesses the validity of models result and data, right? The next one is model transparency, and it evaluates if the model's explainability and feature target codependence are on par with real world understanding, right? Model safety assesses the model's fairness and decides if the model is biased towards any certain groups, right, or any certain set of individuals or certain individual, right? Security and privacy, as I said earlier, evaluates how robust the model is to various adversarial attacks, and also safeguards from any privacy concerns, as I spoke about it earlier. Now, the way AI Trust Calculator works is that the user needs to provide a model training dataset and a validation dataset to use the AI Trust Calculator. The user needs to answer questions regarding each of the above four components of trust, based on which we calculate our AI trust score. Now, what we have done is that we have built this score and we are open sourcing it, right? So we are contributing back to the community as an open source asset, right? Now, what I will do is, I will try and explain, this whole trust component with a machine learning use case. We can also do with a deep learning use case, but I will try and do with a simplistic machine learning use case, which is around churn prediction, right? So the overall purpose of having a robust churn prediction system is to be proactive in customer engagement and customer problem resolutions, and hence avoid a potential churn or potential attrition, right? That's what it is. So our goal here is to build a trustworthy churn prediction model which is not only robust in predicting potential churners or potential individuals who will churn, but also help illustrate the AI trust framework that we're talking about, right? So the problem statement is to build a trustworthy AI automation which learns from anonymized customer data to identify early potential churners, at a time where we can take some action, right? I mean, identifying a customer just when they're about to churn or they have already churned doesn't help. So the solution approach is to access anonymized historical customer behavioral data, right? And then design and develop AI model, which we have done leveraging our Hypersense AI trust design framework, and then quantify AI model on various parameters of AI trust and compute an overall trust score, right? There is certain assumptions and there are certain methodologies that we have used for overall trust score, and we'll talk about that when we go to the demo of the tool. Now, when it comes to the data that we are leveraging here, the data set has got demography information about the customer. It has location information, some population level data, and what kind of, and this is a customer churn data for telco, so it has got different telephonic and value-added services that the customer has used or is using, and then the status, right? What is the customer lifetime? What is the customer lifetime value? What is the churn status? Why they have churned out? So this is the training data set that we have, and we have trained a simple logistic regression-based model on selected features, and then build the model, right? And we have leveraged Python to build the model, right? So now this is the AI trust calculator, which we are contributing back to the open source world, but open source community. But I'll directly go into the calculator and talk about various aspects of calculating trust, right? So you said there are four different elements: technical robustness, model transparency, model safety, security, and privacy, and we'll look into each of these as and when we go. But in the first stage, are you able to see my screen? If you can confirm, if you can see the calculator, or
No, we can only see the slide deck with the live demo and with the link. Oh, now it works. Cool.
perfect. Sorry, so this is the calculator, right? Which is there, and let it open. Yeah. So this is a trust calculator, right? This is an open source, as I said, right? Open source contribution from our end to the community, right? And the first thing, as I said, right, there are four different elements as far as trust is concerned, and they are technical robustness, model transparency, model safety, and security and privacy, right? The first thing that we do is to upload the model. So as I said, it's a simplistic logistic regression based model that we have built, and it's a classification model because we have built a churn prediction model, which basically classifies each customer into potential churners and non-churners, right? So what we will do is we have to upload the pickle file here, and let me go and upload the pickle file. Give me a second. Yeah. So, and then you have to answer a set of questions which are there, right? So once you upload the pickle file, there are a set of questions which are there. Are the model performance and outcomes validated, right? Is the model performance in each iteration or trial experiments tracked? So if it is tracked, you say yes, otherwise you say no. Are the model iterations or experiments version controlled? If it's controlled, you're leveraging a good MLOps framework, then you say yes, otherwise you say no, right? And then in the next stage, you upload the training data set, right? So you go ahead and upload the training data set, and as soon as you upload the training data set, you will have some set of questions around model performance, and they are: is the data source validated, right? If you don't have confidence on the data source, you say no, otherwise you say yes, right? Is the data transformation reviewed and approved? Is data information fully or partially available, right? Does the ML framework have latest build or release, right? And you say yes or no based on your understanding. In So what we would recommend is that if you don't know a particular answer, it's safe to go for no, because the risk of calling a particular system trustworthy when it is not is much higher than not calling it trustworthy when it is, right? So our recommendation is select no if you're not sure about the answers. Now you select the record ID, and record ID means the entity at which the model has been built, and you select the target variable here. And the target variable here, as we know, is the churn, right? So we select churn, um, and as the next step, right, we go ahead and look at the technical robustness. Now the technical robustness is around model expected performance. You can have a lot of metrics. Currently we have a smaller number of metrics. We are looking at accuracy, AUC score, precision, recall, and F1 score, but you can have kappa, you can have other metrics as well, and we are working on that, expanding this list and having more number of performance or robustness matrices. And you can define the threshold that you want from the model, right? So whether you want accuracy to be 75, or let's say I want the accuracy to be 80 percent, right? I want AUC score to be, you can set this threshold, right, on performance, right? And the next step is around drift analysis or model validation. So what we are doing here is that we are looking at data set drift. The question is, have you ensured the training data set is closely dependent to real data validation data? You say no. Now typically you monitor drift in production, right? So when your model is in production, you because there's a time component to it, right? Your data set, your features can change over time, right? And there can be concept drift, there can be, so you can have different types of drift, and you do it in production. You can do it in production as well, but here we want to show very quickly, if there is a drift, against a particular set of data itself, right? So you go ahead and upload, your validation data set, or another data set with which you want to basically measure, potential drift. And then you go to model transparency, which is around explainability. And you basically, when you say no, it will perform all sort of explainability here. You can do global as well as local explainability. At this point of time, we are only doing global explainability. We'll show you how. But you can do a bunch of explainability also. Now, this section, when it comes to model safety, is to evaluate whether you have performed model bias detection and ensured model is safe to deploy, right? So if you say no, not analyzed, it basically does model bias assessment, right? You can choose an option. Now, in this case, we say that bias favorable model response is no churn or non-churn, right? And let's say, the privileged group, or the ones which are likely to have bias, are male, right? And so if male are, I mean, we are, our assumption is that male are more often than not indicated as non-churners, and females are not. Let's say we have that assumption, so we select one here, we select zero here, and then we give answers to these questions, right? Are the scenarios where ML decisions tend to fail identified and execute from the prediction services? Are the excluded scenarios from the prediction service guarded with satisfactory business rules? So you say yes or no based on your experience, and you go to the last tab, which is around security and privacy. And this is very important. This basically looks at the model vulnerability towards adversarial attacks, and ensure that the model assets are safeguarded, right, from privacy concerns, right? So you just say no, did not perform, and then it will perform all sort of you know um, adversarial attacks, test, right? Whether and then it, the other point is around, do you want to use the same data set or want to upload a new data set? You can select yes or no. I will use the same data set because of paucity of time. And then you can answer a bunch of these questions around privacy, right? What I will do is I will submit, because I'm left with 5 minutes. So I'll submit it, and I will let the calculator work. Right now, what it is essentially doing is, and backend, is that it's basically assessing the model on each of these elements. But the most important element, or basically one of the most important element where we're doing a lot of work, and where the community is also doing a lot of work, is around adversarial attack itself, right? Now, it's not only important to detect adversarial attacks, but also see that how we can combat adversarial attack. And we are doing a lot of work in that regards, right? Where we are looking at the pre-processing stage itself, if we can control adversarial attack or not, right? Now, what we have done is that we have evaluated four types of adversarial attacks in our calculator, right? And they are evasion attack, poison or poisoning attack, inference attack, and extraction attack, right? And we'll look at it, each of these, in a bit, right? It will take a little bit time, about a couple of minutes before the result will be there. But just to give you a view that what each of these attacks are. So evasion attack, is nothing but where you carefully, manipulate or perturb the input data during deployment, right, or in production, to deceive, previously trained classifier, right, and have them, misclassified. That is, evasion attack. And then, of course, I'll talk about other attacks also in a bit. Now, you see here, these are the results which are there, right? The AI trust score is coming out to be 51, right? Remember, we have given the flexibility at this point of time to change a few of these levers, right? So for you, if security is most important, you can go ahead and change the lever, right? So you can decrease this and you can increase other, right? So you can do all of those sort of things, and then it calculates the trust score based on that, right? So you can do a bunch of these things, and then come up with your own trust score. But the point is that while evaluating the trust score, one of the important consideration is that, so 78.5 is the trust score that comes, that what is important for the given use case or given system is very important to determine, right? At this point of time, you see the target weight for each of these influencing factors are same, which is 25% each, and you have number of metrics that have been evaluated. We're expanding this list, right? So currently, if you see, there are 13 performance metrics which have been evaluated, 4 explainability metrics, 5 safety metrics, and 10 security metrics. But we are expanding this list, and then you see that what is the compliance in terms of meeting the threshold, right? So these are number of non-compliance, right? And we'll look into it, each of these in a bit. Let's look into the reports, right? So on performance and robustness, you see, what was the target accuracy that we aimed for and what did we got from the model, right? And same, with others, are is AUC, area under the curve, and precision, recall, and F1 score, right? If you see on all the metrics except AUC and precision, the model was subpar, right? Or the performance was subpar. Now we also look at model stability, right, when it comes to robustness, and here we look at drift, right? So you see here, we have looked at chi-square, as the measure of drift, and in this case there are no drift which have been detected, right? So there is no drift which has been detected, right? So we look at drift also, or data set drift. In this case, we are also coming up with other drifts, as well as data quality monitor, because that is also very, very important. Now in model transparency, we have looked at, of course, variable importance chart and the partial dependence plot, right? And based on that, you come up with the score. On model safety bet, right, we have looked at biasness, potential bias, right? And we have looked at disparate impact ratio. You can look at other matrices as well. So we are including matrices like, it's already there but it's not there in this particular version, where we have looked at odds ratio. We have looked at bunch of other measures for biasness. In this case, if you see, that it's coming unbiased because it's between 0. 0.8 and 1.2. Now coming to security and privacy, I was saying there are 4 different types of adversarial attack which are there. So if you see here, what has been done is that we have done a slight perturbation or manipulation on different features, right, to basically see that how the model result changes. And if you see here, in here, if you see, when we have changed, there is accuracy which has come down, right? While recall has improved, F1 score has improved, accuracy has come down, as well as precision has come down, right? So this is evasion attack, where you perturb the input data, or very carefully perturb the input data and deceive the trained classifier, right? To make it misclassified. Inference attack, is when the attackers aim, to figure out whether the set of instances which were used for training, they were the same or not, right? So they basically try to imitate, the set of instances from the training data set, right? And they use the model's performance on the instances to figure this out, right? The assumption is that the model perform better on trained instances than unseen data, and that is invariably true, right? I mean, it's a case of overfitting. This is also done in production, so we have evaluated that. See, the attack success rate is 0.5. 0.5 is equivalent to random guess. So inference attack is not happening in this particular case. Poison attack is when you change very small number of instances, right, or 1 or 2 instances in the data, you poison it, right, and then you change the model performance. So in this case, you can see which is the poisoned point. So if you see here, this particular data point, it has been changed, right? So each of the features have been changed, and what is happening, we have changed only one value, and there is some impact on both train as well as validation accuracy, and this is poison attack. Now one of the attack is extraction attack, right? An extraction attack is when attacker gets the prediction of multiple instances by querying the model iteratively, right? It's like stealing the model, right? So ideal scenario, in this case, is that attacker is able to completely replicate the model performance, right? It is done in production, right? If in this case, if you see, this is the original model and this is the attacked model, the accuracy is nowhere near precision. accuracy is in the ballpark, but precision is pretty low and stuff. So what we do in this particular tab is that we see that which particular types of attacks were there. So evasion attack was detected, poison attack was detected, whereas inference and extraction attack were not detected, right? So net these are different ways to evaluate trust in AI model. Because of paucity of time, I'll pause here and can take any question offline if you have. Thanks a lot.
Hey, Shashank, sorry to cut you off, but we've got about like 1 minute left, so you may want to wrap up.
Yeah, I think pretty much that. So net what we want to build is a full-fledged trust calculator, because if you see today in our community we don't have a full-fledged trust calculator which can give a trust score for all the depending on all the parameters or all the influencing factors of AI model. And that's what the intent is, to build a full-fledged trust calculator and give a net trust score, so that enterprises can adopt it looking at this trust score, right? Threshold trust score being 80, whether we should adopt it or not adopt it. So that's what the intent is, and we wanted to present a quick framework for that. Thanks a lot. Thank you.